Hey, in this one I wanted to show you how we can add generics or templates to our lambdas to make them a lot more concise. So here I have just a main with foo is equal to 42. Let me create a little lambda that will take an int x and return x times 2, like so. And then let's just print it. F is equal to f of 4, let's say, like so. This should be 8. Oh, yeah, okay. I wanted to put foo here, so this should be 84. Yes. And now we would like to accept any kind of arguments, not just ints, like any number-like argument, anything that implements the times, the multiplication operator. Let's say I want to pass a float, which, okay, implicitly converts to an int here, but you see that if I do this, it's quite strange. So let's instead use auto, and auto will basically generate a template for you. And you can see now that it understands x as being a float. And like this, it's somewhat useful, but it's not super useful. I use them generally because you want to keep lambda very concise, and typing like the whole type name in C++ is quite annoying. So let's say I have an optional float, O is equal to 42 times 42, and here I want to do x value this up, like so. And this should work. The of main. Oh yeah, with foo, I need to put it with O. And so yeah, this still works, but here I didn't have to type the whole std, optional, float, and so on and so on. And yeah, as your types grow in size and the templates become more complex, you'll be very glad to have auto at your disposal. By the way, this also works for regular function, not just lambdas, but yeah, lambdas support them as well. So yeah, let me give you a more concrete example of how you could use this, which I pre-written. So, oops, this. So here I have two containers, a vector and a list, and I have a function which applies a transform to it, and this lambda has a lambda inside of it, so it's lambdaception, and it takes any kind of reference to a container and applies a transform that multiplies by 2. And you see that I can apply this function to either a vector or a list in this case. Up, and it will work. So you see that yeah, the thing was applied on vector and on list, and yeah, it basically created 2 copies of the function, one for vector, one for list, as you'd expect. There is a slight issue with auto in lambdas, which is that it's harder to enforce some arguments to have the same type. So let's say I have foo and bar, which are both int, and I want a function that takes any kind of number, x and y, and does their addition, so x plus y, like so. And let's do auto r is equal to f. Here we pass foo and bar, like so, and we print the results, like so. And yeah, if I clear the thing, so it's 66. But now you can see that I can add, like, if this is a float, I could theoretically like add a float to an int, and let's say I don't want this kind of behavior to be allowed. I want to x and y to be forced at compile time to be the exact same type. There is this new option where you can pass templates, template argument, templates, parameters, I don't know how they're called, but templates to your lambda. So you say type name, just like a templates, and here you can enforce that x and y have the same type. And so this shouldn't compile. Indeed, it doesn't. But if foo and bar are both floats, this time it works. So yeah, this is just a nice little thing to, sometimes you need to enforce some types on your lambdas, but you still want generics, so you can do this. Anyway, that's all I got for now, and yeah, see you in the next one.